we will multiply now the squared deviation times the relative frequency. We have 295.84 times 0.28, taking into account that there are only 28% of the entire sample that are within this younger age group. Next, the squared deviation is 51.84, and we multiply this times 0.24, 24% of the total, giving us a value of 12.44. Next step, 7.84, the squared deviation, times the relative frequency, 0.16, for a value of 1.25. Next, for the fourth group, squared deviation is equal to 163.84 times 0.12, the percentage of people in this group, for a value of 19.66. Finally, the oldest group, their squared deviation is 519.84 times 0.20 for a value of 103.97. Finally, to calculate the sample variance, the sample weighted variance, we must add these five numbers together. 8.284 plus 12.44 plus 1.25 plus 19.66, 103.97 gives us a value of 220.16. This is the sample variance. There is a small correction required for this value. Recall that the sample size is 50, and implicitly we have divided by 50 to calculate this sample variance. But as an estimator of the unknown population variance, we should in fact divide by n-1, 49. To make this correction, we can multiply the calculated variance of 220.16 times 50 minus 1. In this case, we would multiply by 50, divide by 49, and we now have the corrected sample variance, estimated sample, corrected sample variance of 224.65. The very last step is to calculate the standard deviation, which is simply the square root of the corrected variance. In our case, the square root of 224.65 is equal to 14.99. This is equal to the sample standard deviation.